we will be having Shankar and Chandralekha from Presidio for presenting us on Flex CD and their experience over Flex CD. So over to you, Shankar and Chandralekha.
Hi everyone. I'm Shankar. I'm working as a senior cloud engineer in Presidio. So here I have Chandralekha with me. So Chandra, you can introduce and let's start.
Sure, Shankar. Thank you so much. And hi everyone. I'm Chandra. I'm working as a senior engineer with Menaka, Kavin, and Shankar, all the people in Presidio. And I have 4+ years of experience here and started my career as a software engineer trainee and then got into the cloud and DevOps thing. So, before jumping into the topic, I'd like to thank the CNCF community organizers and the team who are making this wonderful events on a regular basis and giving us the opportunity. And thank you for each and everyone who joined us today for scale their knowledge in different aspects. Okay. And today we are going to present or talk about the Flux CD. This is one of the interesting tool which most of the people are using on different projects along with Kubernetes. And we would like to make this as a little bit interactive session rather than presentation. So feel free to ask any question during the session. And if you have any questions or points to share, you can make use of the chat or you can unmute yourself and talk about that as well. Okay. And before jumping on this particular topic, I'd like to know if anyone in this group have any experience on Flux CD or any other CD tool with Kubernetes. Okay, we are getting some.
Yeah, I worked on Argo.
Okay, that's nice. And Joe
But
said he's also using Argo CD and any other.
I mean, I tried Flux CD,
Okay.
which is an add-on that is given by Azure, but I don't know, for some reason it was not a good experience, at least.
Okay. Cool.
Maybe
Okay.
we'll talk that experience at the end of the presentation.
Sure, sure.
Yes. Yes.
Yeah.
Okay. Thank you, guys. Okay. Let's jump onto the topic. Yeah, Flux CD is something which we are using with Kubernetes. So, Shankar, first slide, please.
Yeah.
Yes. Yes, this is basically a CD tool that is being used for the Kubernetes deployment to host or deploy the Kubernetes resources in the cluster, right? So what we used to have in the traditional way, let's just look into that once. So in traditional approach, we usually make use of the native kubectl command and basic Helm charts to deploy or manage the all Kubernetes resources in single cluster or multiple cluster in Kubernetes, right? So it will have a lot of issues in terms of manual intervention and lack of consistency, and it requires a lot of labor work in terms of making it as a traditional way, right? So if there are a number of challenges that we can say or list, right? So with Flux we can
Oh, sorry.
yeah, sorry. With Flex, we can automate this and overcome all those challenges which we are facing with the traditional approach. So that's where comes into picture. And Flux is basically automatic synchronization between the desired state and the actual state in the environment. Okay. With this Flux is mainly using one fantastic concept called GitOps. Okay. How many of you know or have some rough idea about GitOps?
Maybe the people who worked on Flux and
Flux
all.
or Argo CD, they usually have the basic idea of GitOps, right? So yeah, this is nothing but there is one term called reconciling or reconciliation. That is nothing but synchronization between the actual state, desired state, which is in the any of the I would say the source control, and in the actual state of the environment. It could be any platform. It's not specifically to Kubernetes. It's just basic for any application deployment or whatever. Okay, so there is some agent called a reconciler. So what it will do, it will keep on monitoring the desired state or the source which are available in any of the VCS tools, like either it could be GitLab or GitHub, Bitbucket, or Azure DevOps repository and code commit, anything. So it will keep on monitoring the source control, and if there is any change occurred or any event happens in the desired state, it automatically pull those change and make the actual or corresponding deployment changes in the actual state that is on the target environment. It could be any cloud provider or any other platform which are open or available so far. Okay, so in this GitOps, it make use of a number of principles like reconciliation and I would say the declarative configuration. That is nothing but we usually give or what it will do. For example, if you want to create a pod or deployment, we'll just prepare a script or make use of the kubectl command to create a pod or deployment, right? So here with GitOps, we'll just prepare the declarative configuration and put it in the any sort of VCS tool, and then once it's set on the VCS, the GitOps will act as an agent to pull the changes and put it in the end environment or target environment. That is what the declarative configuration means. And it also have the enhanced security in terms of pulling or pushing the changes in any environment and so on. So it will also have the specific concept of rollback option. So if there is any failure or misconfiguration happened in the latest or previous commit, it will automatically help us to roll back the changes quickly and very easily. Okay, and with respect to GitOps, there are two approaches which are available. One is push based and another one is pull based. Shankar, next slide please.
Yeah.
Yes, with push based, if you can see in the screen, we usually have the application repository, and if there is some and the native build pipeline, it could be any sort of pipeline that we can name it. So it will when we put or commit any changes to the application repository, we need to have a trigger to trigger the respective pipeline. For example, if we take GitHub, workflow is the one of the option to find the changes or trigger the respective pipeline if there is any changes occurring in the application repository. So it will trigger the pipeline, and pipeline will look for all the changes and push the build the process. Like for example, Docker building. So we usually have any Python or Java application in the application repository, and the build pipeline will read all the data, and with the help of build specification that we mentioned in the pipeline, it will build the particular application into a Docker image. And once that Docker image is built, it will push the Docker image into the image repository. It could be Docker Hub or anything. And once we are done with that, it will also have or help us to do the updates on the environment repositories as well. Environment repository is nothing but we would say like the the declarative configuration or Flux configuration that we usually have in the repository. That is what the environment repository call. And once this environment repository is got updated with the latest changes, it will trigger the deployment pipeline, and the deployment pipeline again do some manipulation with respect to manipulation or the actions with respect to pipeline specification that we are giving on it, and it will deploy the changes or the actual changes in the environment, the target platform. That is how the pull based approach push based approach usually works. Okay. And whereas in the pull based, next slide please. Yes. Whereas in the pull based, the first right side of the thing are usually the push based mechanism, and if you see on the the right hand side, so the image registry and the environment repository are up to date with the latest changes, and in between the deployment and the registry, we have something some agent or some operator. Here in our example, Flux is one of the useful available operators which are in the market. So we'll consider here FluxCD as the operator. It will observe or monitor these two repositories and the registries on a regular basis. And if we notice any changes occurred in the registry or repository, it will pull those changes and manipulate or do some analysis on the changes, and then it will get into the deployment state. It will go and deploy the changes in the deployment or the actual target environment. So for example, the Kubernetes cluster, we would say here. So this is how the pull based approach works. So how it is finding if there is any changes occurring in the registry, that is based on the hash code which are keep on updating whenever we are making any changes or committing to a particular repository. So it will find the new hash code, and then it will extract the data with the help of that hash code and do the deployment on the target environment. That's how the pull based approach working. Okay. And and I would say this FluxCD is actually make use of the pull based approach for the end to end CD, that is continuous deployment uh, operation. Okay. Next slide please. Yeah, here if you see the same approach, on the left hand side, we have the number of the source controls, either it could be GitHub, GitLab, or Bitbucket, whatever. So we have all the VCS tools over here, and we are pouring all these all the application code or cluster configuration, whatever. So we are having all those configuration over here, and in between we have this Flux operator. So it is keep on monitoring the VCS tools or source controls, and analyzing or look for any changes that are occurring in the left source of source control. So if it finds any changes occurred, it will automatically pull those changes or observe those changes and reflect it in the actual state on the Kubernetes cluster. This is how it make use of the pull based approach with GitOps, and do the deployment in the Kubernetes cluster. Okay. And move on to the next slide. Shankar will take over.
Yeah, thanks, Chandra. So just before we start with this, I want to take a pass here and take few questions if there is any. Is there any questions?
A quick question from my side. How easy is it to install Flux in any of the this thing in any of the Kubernetes clusters like AKS, EKS, right? Is
Mm.
it the traditional way of doing stuff, or uh, like the thing is like also the UI part is a little bit different, right, than Argo CD? So
Yes.
is there anything that helps us there?
Okay, so when it comes to installing Flux into our Kubernetes clusters, like we can add an extension. Okay, usually cloud providers like Azure, AWS, and I think GCP also provides those extensions. If it is, let's say, we have our Kubernetes cluster in our on-prem. In those cases, it's just like a traditional way how we install the CLI tool. It's just like that. So also when it comes to cloud providers like Azure, AWS, all those things, we have something called Terraform. I think most of you here would be aware of it. So we have a plugin, like a module for that, so we can automate that process too. Yeah. Does it answer your question?
Yeah. So it's the same ways. Okay. It's more like the cloud native approach of installing stuff. Got it.
Yep. Right. Right. Also, in a demo, we'll see how we'll be doing that. Okay. Okay. Is there anything else? Okay, so I'll take the snow. If any questions, keep it for a QA, the last of the slide. Okay, so now we are going to look at the Flux controllers overview. So till now we have seen the Flux is something like a push-based approach that Chandra explained. But here, how Flux works actually. So there are multiple components under Flux. Those components, I will call it as a controllers. Okay. So there are controllers like source controller, which will be in sync with our source control management, and it will look for the recent hash changes. Once, if there is some hashes, like some changes pulled to any particular branch, so here we can connect any particular branch, let's say main, or for a dev environment we can connect dev branch. So like that we can connect any branch to this source controller. So source controller will pull those changes, and there will be something called customization. Okay, so customization, there is something called customization controller, which will create a customization, and it will deploy the resources to multiple tenants. Okay, and then when it comes to Helm controller, like in our like traditional approach, what we used to do is like we'll package like a set of instructions or set of configurations as a Helm chart in some Helm repository, and we'll be doing a Helm releases. So those will be taken care by the Helm controller. And also we have one more feature that is interesting, like there is something called notification controller. We can notify on any events if we need to. Okay, so we'll be looking that in detail in the upcoming slides. So here, we'll be looking into the source controller. So just I wanted to mention one more thing, like Flux is built on top of Kubernetes APIs. Okay, so since we'll be connecting multiple source control system to the source controller, here we'll have multiple CRDs set up in the background. Okay, so the source controller will make use of that CRDs, and then will up, like fetch the artifact and store it, and then it will apply. Okay, so that's how the source controller works. And then when it comes to customized controller, um, Customization also, like here we will be having something called infra repo, that is a repo where we store all our Flux configurations, and those will be stored as a customizations. Okay, so here let's say we have different environments like dev, stage, and prod. Here in our Flux repository we'll be storing a separate customization for each environment. Okay, so this customization will take control of that, and it will look for that customization that we configure in our um, Flux configuration. I'll be showing that. So yeah, this will be taking care of all those customization releases and everything. And then when it comes to Helm controller, it does the same thing. Here we'll be connecting to the Helm repository. Okay, if it is a private, then all those credentials will be stored in some secret, and Helm controller will utilize that and connect it to Helm repository, and will be making Helm releases. So that Helm stuff is completely taken care by the Helm controller. And also we can configure some of the notifications, like whenever there is a change in a Helm chart, or whenever there is a change in Helm release or new release have to be taken, those kind of events can be notified. So yeah, so here a notification controller will be having some configuration for let's say there is a Helm release, then do notify to this particular source. So here we have multiple notification options. Whenever there is a change, it can produce a notification to Teams, Slack, Discord. Yes, so these are some of the options that we have in Flux. Okay. Apart from that, so one of the feature that I I think that is interesting is about image automation controller. So we'll be seeing this in detail during our demo. So here, image automation is something like we'll be having a deployment file that is used to um, deploy our application. There we'll be having a tag, image tag, and whenever there is a new image pushed to a image repository, we need to make change to that particular deployment file and then push it. Then, like, these are all a manual step that we have to take care, right? So here image automation controller will take care of automating this manual steps. So here we have something called image reflector. Okay, it will be continuously looking for our registry, and so we'll have something called image policy. Okay, you can see that here in the configuration. So image policy, there we can configure multiple things, let's say based on tags, based on latest push, something like that. We can define a policy. Based on this image policy, image reflector will look for the ACR, and whenever there is a new push in image, then image reflector will send a event to image automation controller with the namespace and policy name and change in the image with the tag. Okay, and those information will be updated to the git source control with the help of image automation controller. Okay, we'll see this in detail, but this is the high level of the flow. So yeah, I'll leave it to Chandra. So can you explain the benefits of Flux, Chandra?
Sure, Shankar. Thank you. And talking about the benefits of the Flux CD tool, as we already discussed, it make use of the GitOps for the end-to-end automation of the Kubernetes resources in the Kubernetes cluster. So that is one of the plus to avoid all the manual intervention and the effort that are required to do or monitor and maintain the resources or the applications that are running in the Kubernetes cluster. So with the help of this automation, we can both manage and maintain the resources in Kubernetes. And the next one is security. In terms of security, it makes use of all the options, and it since we are making use of the declarative configuration approach, so everything will be set in the source itself, and there won't be any exposure to any security vulnerabilities to the internet. That is one of the plus with Flux CD. And scalability. For example, currently I'm working for a small scale company, and I'm making use of the Kubernetes for deploying their application. And what if in the future the companies keep on growing, and they are having today they have 100 plus users, and in the next 6 months onwards they are having uh, 10K plus or 100K plus users. At that time, we need to manage and do the scaling up according to the amount of request or the user approaches to the application, right? So with the help of FluxCD, we can do the scale down or as well as the scale up with the for our Kubernetes resources. That is one of the main benefits. And declarative configuration is, as I mentioned already, so there won't be any configuration mismatch or misconfiguration happening if we have everything and defined and properly structured in a way to maintain and manage the Kubernetes cluster with the help of the configuration. And extensibility, yeah, it's actually both scalability and extensibility. So we can extend it or to the max based on our use case, which are keep on changing based on the different factors. For example, the application overload or the user increase of user traffic or whatever we can name it. And since it's an open source, we do have a lot of community support from the Kubernetes native thing. So it's all the benefits of Flux CD. And it does have a number of challenges as well, but we can overcome those challenges with addition of some other either open source or paid softwares integrated with Flux CD. So next slide, please.
Yeah.
Yeah. So complex configuration, that is nothing but like when we are growing or increasing the complexity of the Kubernetes cluster, so it will also make the configuration a little bit complexer. So in when we do in that way, the complex the pipeline is also getting complicated, right? So that is something we need to give or take more care about in terms of designing and handling the dependencies and the integration with all the other options or tools that are going to be involved in the pipeline with respect to FluxCD. And learning curve, most of the people most of the people don't have much exposure to the GitOps concept or the FluxCD tools, so it may affect or need some amount of knowledge sharing or basic um, I would say the learning that are required for the people who don't have any exposure to the GitOps concept, as well as it is quite complex to explain to the customer when we are deploying or making use of this FluxCD concept. So it always the same, right? So we need to convince the customer before implementing anything on their environment. So that is something need extra effort to give the end-to-end knowledge of how it is working and what are the benefits and pros and cons, everything to the client, and convince them. That is the quite tricky part here. And handling the secrets, here FluxCD doesn't have any native approach to manage the secrets, so we should definitely make use of other SOPs or GitHub secrets or other options or Kubernetes secrets to store and manage all the credentials securely. And we need to do some extra effort to integrate with the FluxCD pipeline. So, and then when it comes to large scale deployment, it is quite tricky to optimize it because when we are scaling, so the deployment is being the same, but if we miss the optimization part, the we need to pay for the lack of performance, availability, and other areas of the application benefits. So we need to spend more time on the optimizing the deployment approach, how we gonna design the process and plan the deployment stuff, and then only we can once we confirm the optimizing the end-to-end process, then only we can get started with the actual implementation that is there. And if there is any failure occurring in the deployments, it is quite hard for us to track or troubleshoot and find the root cause of the particular failure. So there is no native approach to help us to find the root cause whenever there is a deployment failure happening. So we need some other tools like Prometheus or whatever the other data analysis tool or logging tools which are available in the market. With the help of all those logging mechanism, we can improvise this thing like managing and what I would say, like reduce the time of finding the root cause of the failure and fix it as soon as possible. And multi-cluster management is like for example, I have one single cluster and it's quite easy for us to manage in terms of the automation and other configuration stuff, right? But when what if we have a number of clusters and which are all integrated with each other, and it's quite complex in terms of networking and security wall sorry other terms. So it is quite hard for us hard to manage with the help of the same FluxCD. So we may need to go for some extent or look for other additional integration tools or plugins that are available in the outsource, and and then only we can do the better job with respect to the multi-cluster management. These are the challenges that we thought the actual barriers for going with the FluxCD for the large scale application or the large scale projects or customers application. So I'd like to open this forum for asking any question, or if you face any other challenges in your experience with respect to FluxCD, feel free to share it here so that we'll also learn it from you guys.
So one question I have, that is
Yeah.
regarding that image tag syncing process.
Mhm.
So basically, suppose if I have one single ACR that I use for dev and QA deployments, and I deployed a latest tag. So how Flex will able to figure it out that this latest tag will deploy in dev or QA, or it will deploy in both the environments?
Actually, we should be designing like uh, two different repository in a ACR. So in a ACR, we can have multiple repositories. So there, we can have two different repositories, one for dev, one for stage and
But
prod.
that will be an extra headache, right? Why would I go with that approach? Like it should be build once and deploy a multiple approach, right? I build a single tag and deploy in each and every single environment so that I can have better traceability and better observability that I am deploying this particular tag in all around, and so that it will give me more leverage when sometimes some audit or something monitoring things need to be done. Otherwise, how will I give the tag sustainability, that this is the same tag we tested and this is the same tag we deployed.
Okay. So here I'll take a two different perspective. One is like we have a different branches in our source control, like main dev. Let's take it as a two environment for ease here. I'll say dev environment and prod
Mm-hmm.
environment. Okay. So
Mm-hmm.
now I have two different branches, and let's say there is a configuration change in our
Correct.
sorry, uh, this is an application repository, and there are new features added by the developers. Okay. Now these features are merged to a dev branch, and that needs to be
Mm-hmm.
tested in our dev environment where a set of users are different. That is our developers and testers. But when it comes to production, it will be our end users. So
Mm-hmm.
how I would design this scenario is like I'll have either two different repositories, one for dev, and I'll push all my dev changes as a dev repository to dev repository. And once it is tested, looks good, and we promote it to prod, then I'll make a actual prod release, that is like build and push the prod image with the changes or any testing or any bug fixes to this prod environment to a different repository that will be deployed to a different cluster.
No,
And
that's okay. If you're talking about prod and dev, then that no one is using, like no one will use the same cluster for prod and dev. That's correct. And ACR will is also different. So
mm,
that is the place this scenario will work. But
yeah,
in
I'll
lower,
mhm.
how
Yeah,
you
sorry.
will differentiate?
Uh, okay. So sorry to interrupt. Like, this is one of the perspective that I see. Like in
Hmm.
your scenario, you are expecting a single ACR repository, and that
So
you
that is
need
not
to.
possible, right? Basically, that is what, like, so other way around we can do, like, yeah, we can configure the YAML that way around, we can do, of course.
Mm,
We can use the customized tool in the YAML where we can update the tag and push that file, then that particular file will deploy in that respective environment. That is a way I think it works, right? But with this image tag syncing, where ACR will update and sync will happen, this will, if multiple environments are attached, it will update in all the environments. That's what I thought. Correct.
Um, so
I
you're saying we have a repository, uh, a single repository, right? You're talking about, or a different repository?
so I would.
ACR. Yeah, yeah, then can you join, yeah, please.
Yeah, yeah. So I would take a different approach here. I would focus more on tagging the image with the dev, with the branches, dev branch, master branch, or whatever branch that the user is working on, right?
Yeah.
And do an incremental promotion, right? So
Yeah.
first aspect would be like having multiple ACRs is also for dev environments doesn't uh, it's not very cost effective,
Not like,
right?
yeah.
It's expensive, right? And the idea would be that you create multiple repositories within the same ACR, but you tag your images in a different way. You can timestamp it with a dev branch, hyphen dev something, the
Yeah.
hyphen, or if you put, if a dev branch is merged to master, then the tagging should change to master and it push. You can use the same ACR or you can use a different ACR. It depends on however you want. So rather than, I
Yeah,
would say
basically.
it would be the better approach is what my input would be.
Yes, yes, yes. I agree. I agree. So basically, what you are saying is to tag it with a branch name for forward, like then either timestamp or commit hash or
Yes.
anything.
Mm,
That would be a better approach
yes.
rather than getting a. But that scenario will again lead us to that audit scenario where we, if you want to go for a same tag, where basically auditor will ask you why you tested this particular tag and then you deployed a different tag. Because this way, if you're testing a QA, suppose you have a QA environment where you are testing this particular QA image, and then in the master build will again for my new tag out, though the image will be same, it will be the retagging only, but the auditor will ask you that why the tag is different. So in that scenario this image sync won't work, but the YAML changes can work. That's what I think.
Okay. So here, you're saying like us with the same commit or the same hash in the tag, and we use the same for test environment and the same for prod environment with just the YAML change, right? Here we have something called as a image policy that we can leverage off. Like we can have a hash, okay, and then we can have that hash in a variable in our like a variable in our pipeline, or let's say there is a push to a dev branch, and we tag it as dev hyphen some hash, and so image policy will look for the pattern, and then it will deploy in that approach.
Yeah, yeah, got it. Thanks.
Yeah.
Another question I have is like how different it is from Argo, like Flex versus Argo. If you give some pointers.
Okay, so when it comes to Flux versus Argo, I have a very limited experience with Argo, but the difference I see is the user interface. Here with Flux, everything is a CLI, and then with Argo, I see there is a user interface, everything, and there is authentication mechanism that we can set in Argo. But here it comes to Kubernetes authentication. And then apart from that, here we have something called uh, controllers, like different controllers, image controller, helm controller, but I don't see any that sort of architecture in Argo. So those would be the most highlightable changes or the comparison between Argo and Fluxy. um, from audience, if anyone would like to highlight any of the comparison, I'd appreciate that. Yeah.
Also, there is no Helm controllers like native Helm releases that we can't able to do in Argo. But
Mhm.
in Flux, we can able to have a native Helm release, and it will be we can do any Helm kind of CLI thing in the Flux. So it has a dedicated Helm controller that we can make use of. But in Argo, everything is flattened into a Kubernetes manifest, and it uses customization in the background.
Yeah. By the way, it was a nice question. We'll consider this point, like we'll add those points in our PPT as well. Um, so yeah, is there anything else, or let's continue with the demo? Okay, if there is any questions,
And
we'll.
I'd like to add a point here. Like we just started with the FluxCD, and we didn't get a chance to look into or deep dive into the Argo CD part. And I see a few of you guys already had or got some exposure to the Argo CD, right? So and Darren or someone said compared to Argo CD, Flux CD has a number of limitations, and you had a bad experience, right? Could you please share it with us so that it will be help us for us to understand the actual use case?
Is there?
No.
Are you speaking mute or?
Okay, we will take
Yeah,
this discussion later, and we can get started with the demo.
yeah. Okay, Chandra.
Yeah.
Okay, just give me a minute. I'm switching my screens. Okay, so is it visible for you guys?
Yep.
Okay. So yeah, you can you'll be seeing this diagram. So this is like a high level diagram what we are going to see in our demo. Okay. So if you see in a GitHub, we have two different repositories. Okay, one is to maintain our Flux configurations, and one is a demo app. But for this demo, what I'll be doing is I'll be having this demo app from my local machine, and I'll be building and pushing from my local machine to ACR. Okay, I'll be show you. One second. Okay, so this is our ACR. Okay, we have just one repository. Under that, we have our versions pushed here. Okay, I'll show you our app. So our app is just a simple Flask application where I have different versions here. Okay, now I'll update it as version 2. Okay, so I'm the developer. I'm going to push the version 1.2 of it. Um, okay, so I'm performing a Docker build. So it got built, and then I'm going to push it. Okay, so now the image is pushed. Okay, 1.2 is here. Now I'm going to make the change to our configuration. Like we have a deployment file pointing to this image repository, which I have showed you. I'm going to change it as 2. And then we have namespace and services, everything. So if you see the image, we have a Flux controller, that is the source controller in the Flux will be pointing to our demo Flux repo, and it will be pulling a configuration whenever there is a new change, and then it will deploy those changes through customization. Okay, I'll show you that. So there is something called a K9S. It is a CLI based tool. Instead of performing our kubectl commands, I use this K9S. This is a interesting tool which you can look at. But now I'm getting into Flux system. So here we have a namespace called Flux system, where we have all our Flux controllers in a single place. Okay, there you can see a source controller. Now let's look into the logs. Okay, so let's see. I'm going to push a change, and let's see how it pulls in the log. So I made a change. Okay, the change is pushed here. Okay, so before that, um, I'll show you our AKS, that is a Kubernetes cluster. I have set up this in our Azure portal, and here there is something called GitOps. Okay, in the extensions, if you see, we have added a Flux extension that is offered by Microsoft. Since Flux is open source, Microsoft has maintained version of that as well. And now in the GitOps, we can add a configuration here, which will make the customization releases. Okay, I'll name it as demo app conf, and then the namespace will be cluster config. It is a cluster wide scope in the Git repository. We need this URL. Branch main. This is a public repository. And I like to keep the sync interval as 1 minute so that it will pull our changes sooner. So that will be the sync interval. So here we are creating a customization, that is demo app customization, and then the path. So this path will be the path where we maintain all our infra related customization. So here also I'll make it as sync interval 1, and then save it. Next. So that's it. Yeah. So right now we have created um, a, a configuration here that will be reflected in our cluster. It is still getting created. Okay, so you can see the GitOps configuration is created and still the compliance is pending. So I'll show you that. So once the GitOps configuration is created, you can see this source artifact. So you can see our commit message. So this is got pulled into it. Um, cluster config namespace. So this is the customization that we have created. Let's see whether the app is up and running. So this is the namespace. Yeah, we got the pod. I'm going to service to get the IP. Okay, you see we have a 1.2 version here. Okay, so now we are going to automate this process. Okay, in the ACR, so in the ACR we have 2.0. Now we are going to release a 2.1. That will be automatically configured in our Flux repository, and it will be pulled. So that will end the demo. So before that, duplicate. So now I'll be going to a case cluster. So we need to add 2 more controllers, like we need to enable it in our Flux extension. So there is a configuration settings where we can enable if any additional controllers are needed. I have this, and we can enable it. The other one is roof the controller, and we are enabling the same. Okay, let's see if it is enabled. Let's go to pod in Flux system namespace. So we'll be seeing 2 controllers added to this once it is enabled. It's getting updated. So in the meanwhile, I'll be adding some changes. That is, we can add a configuration for image automation. Automation.yaml. So here I have a set of configurations. And in the image, so I'm creating a image repository. Okay, you can see that here. So image repository will be connected to ACR, and it will be looking for changes. Once if there is a change, this policy will set a trigger to image reflector, and then image reflector will trigger the image automation to update our GitHub repository. So that is going to be the flow. So this is the image repository. Now I'm going to add the image policy. Okay. So we need to refer this repository in our policy, and then we are making a range here. That is going to be 2.x, so that whenever there is any minor version released under version 2, that will be get pulled and it will be triggered. Okay. Yes, so it is just the image repository. I'm adding this. Okay, that got added. Yeah, you can see the image reflector and image automation controller added. Okay, let's look for the logs here. But before that, let's see if image policies image policies in our image policies in cluster config. Oh. Once again, that is v beta 2, the which we have added. V beta 2 / image policies in cluster config namespace. Yeah, so we have this image policy added. Okay, so now I'm going to push a new version. I'm going to tag our application as 2.1 and we'll build that. Okay, now I'm going to push the same version. So yeah, once it is got pushed, we'll be looking changes. In our reflector, oh, okay. So I can see the error that it is not authenticated, but so yeah, I need to set up a few managed identity credentials and federated credentials to authenticate. But once it is authenticated, what we'll be doing is like we'll add a tag here. Okay. That is something like this. We need to make a comment across the images that where we need to be added. So here the automation controller, so you see here automation controller will be looking into our demo Flux repo. There it will be looking for this particular comment. Okay, wherever we have added image policy with our namespace and we need to mention our policy name here, so it will update the image automatically. So that's how it's going to work. Okay, once this image is updated, it will make a commit to the branch that we have mentioned in image automation. Oh, one second. Okay, so this is the sample. So this will be the configuration for image update automation flow, and there we'll be mentioning our path, that is /infra. Okay, under infra, in this particular branch, we'll be looking for the looking for this particular comment, and then image automate will be making a commit to this push branch. Okay, with this email and name. If it is required, we can add credentials over here to authenticate. So yeah, once the commit is made here, again a source controller will come into play, and then it will be deployed and we'll be able to see the updated application. So this will be the flow. So yeah, with that conclude my demo.
Mhm. Shankar, a couple of questions from my side.
Mm-hmm.
Yeah. One from the maintenance aspect, right? So we are currently using an extension for installing Flux CD, right?
Yeah.
How frequent are the custom resource definitions updated? Are they updated automatically? Because the add-on will install CRDs basically, right,
Yes.
to deploy the controller and everything, right?
Right.
So, how frequent are there any breaking changes or something like that that we have to update it? Is there a way to update the version of Flux through the add-on, or is it something that we control? How that
Okay.
would be the first question.
Yes. So with that, I'd say that this is a Microsoft managed Flux extension, and like they are little bit slow in updating the latest Flux, and they'll make a delayed release. But that won't be a much delay, but there will be some delay. With that, they'll be having the latest version, and so that version will be installed automatically to our Kubernetes cluster as well, that we don't want to manage any version of Flux explicitly. So we'll be mentioning all these configuration in our let's say if it is a IAC, we'll be maintaining it in Terraform, and yeah, that's how we'll be deploying the extension and managing versions.
Okay. So the follow-up question to that, right?
Mm.
Obviously, we these custom resource definitions are APIs, right? And we might be using some of these APIs like the image update control API that you were using, right?
Mm-hmm. Mm-hmm.
If there's a breaking change, how do we get to know that, right? So, I mean, since
Okay.
the upgrade process is not under our control,
Mm-hmm.
right?
Yeah.
And we don't know when Microsoft is going to actually update anything. We
Yeah.
hardly have any release cycle. That was one of the primary problems that I faced with Flux, breaking changes,
Okay. Okay.
right? And is that something that you, in your experience, that you have plan to meditate that, or how do you identify that, or some workflow that you have?
Yes.
That is one question. The
Mhm.
second question that I have is like, you were using the image you were using Docker images to deploy an application, right?
Right.
The image controller, is it compatible with Helm charts as well? Because Helm charts also have different versions, and they also can be stored in the ACR repository, right?
Yes.
Is it possible, and how that would be your second question.
Okay. So for your first question, I have faced a scenario with one of my client which I have worked in past. There we were implementing Flux, and there was a change in the API that we could not able to get through the cluster. And what we have suggested is we suggested some workaround with the previous API version, and there was a note in a Microsoft uh, Flux extension page that the next release will be in August 2024, like that. So we highlighted those, and we made them understood like until then we need to maintain this workaround. Once there is a new release, then we'll move to the new version of API. So that was the workaround I had to do, but that was not the actual fix. I understand that, but we had no other ways to solve it. Yeah, I'll put it in that way. But for your second question, so you were so what was your second question? Sorry, I missed that.
So instead of Docker images, I want to use Helm charts,
Ah,
right,
right.
to deploy my application, and I want to use the image controller to fetch the latest Helm chart and deploy it.
Okay, so we don't have anything like a latest Helm chart. There, while making a Helm release, we should manually actually update the version by ourselves.
Mhm,
There is no automation in place with Flux currently.
mhm,
It will be like we need to update the Helm chart repository when there is a new release. We ourselves manually need to update the Flux configuration with the latest version. Like image controller will not handle the Helm repository updates.
Okay.
Maybe let's hope Flux brings some controller for that,
Okay.
similar to
So it's
image.
not something that is available out of the box.
Yeah, right.
Okay. Okay. Cool. Uh, yeah, that's the two questions that I had.
Okay.
Okay. Thank you, Shankar and Chandra. Let's, if there is any questions, let's take it over the chats or DMs as we have less time. So, thank you, Chandra and Shankar, for making the session most interactive. Thank you so much.